Hello, everybody, and welcome to today's class where we will continue our discussions on trigonometry that we had started last time, and we will finish off a lot of basics today so that we can start applying the knowledge of trigonometry to do a lot of other things from next time. But it's very important that we study a few important identities in trigonometry, and we try to derive them and make sense of them. Now, in the last class, we understood that there are 6 trigonometric ratios. I will repeat their names. So we have sine, cos, tan. These are the 3 things that we defined. Sine was opposite over hypotenuse, cos was adjacent over hypotenuse, and tan was opposite over adjacent. These were the 3. And I told you that the other 3 are just the reciprocals of these 3. Right? We have to fix an angle, and based on the perspective of that angle, we study these ratios for the other 3 sides in the triangle. So one side will be the opposite side, one will be the adjacent side, the one right next to the angle, and the hypotenuse, which is the largest side in the right angle triangle. That is the one opposite to the right angle. Okay, and we realize that these ratios depend only upon the angle. Doesn't matter how big the triangle is. If you fix an angle, the sine value for that angle will always remain the same. So every single triangle which has that particular angle over there will have the same value for the sine. Okay, so we'll come back to that, but let us see if we could derive a few interesting trigonometric identities. And the first identity in trigonometry, which is of utmost importance all the way into mathematics, is what is sine squared plus cos squared. And now we will try to derive this formula. We'll try to derive this formula and we'll try to see what it is. But here is the thing. We have to use this formula irrespective of what the angle is. Suppose we have this triangle and there's an angle over here. We say the sine of that angle whole squared, the cos of that angle the whole squared, and then we add them together. But there might be another triangle here. There might be another triangle here. And we might have an angle here, and we might have to talk about the sine of that angle and the cos of that angle. So we have to solve this for every possible angle, and we have to see whether it makes sense. So let's call the angle that we want to talk as x. We don't know what angle this x is. No matter what this angle is, this formula should work. So we have to have a sine of x squared plus cos of x squared, and we have to see if this will add up to something. That's what we have to see. So let's keep it very simple. I know some of you are a little confused as to what's going on, but let me take it in very simple steps. The first thing we'll understand is, using the definition of sine, what would be sine x squared? The sine is opposite divided by hypotenuse. Irrespective of the angle, the ratio remains the same, right? Opposite divided by hypotenuse. So this is opposite by hypotenuse the whole squared, right? So this one is adjacent over hypotenuse the whole squared. Is this clear? Does everybody agree with this as of now? Sine x is opposite by hypotenuse, so sine x squared will be that whole thing squared. Cos x is adjacent by hypotenuse, so that thing squared is adjacent by hypotenuse squared. Right? We don't care what angle x is or which triangle. This thing should hold true just because of definition. Now, let's see what it is to add these two things. Just using simple algebra. We're just adding these two fractions, right? So this is o squared plus a squared whole thing divided by h squared. Just by using simple algebra, because the common denominator is h squared. So we have o squared and a squared being added together. Okay, so far so good. So let me write that properly. We have o squared plus a squared divided by h squared. This is what we have. This is just the simplification of sine squared plus cos squared. Now we will have to take help of a very famous theorem in mathematics, which everybody here probably knows. It's called the Pythagoras Theorem. In any right angle triangle, we have a formula that this squared plus this squared is this squared. We have a squared plus b squared equals c squared. But using our language of trigonometry, we can say that the opposite squared plus the adjacent squared should always be the hypotenuse squared. No matter which angle you're talking about, whether this is opposite or this is opposite, it shouldn't really matter. It's just that if you square both opposite and adjacent and add them together, you get the hypotenuse squared. Does that make sense? Is everybody with me when I explain this? So we have opposite squared plus adjacent squared as the hypotenuse squared in any triangle, just because it's a right angle. So in any right angle triangle. So this just becomes simplify. If when we simplify this, we get h squared over h squared, which is 1. So what this means is that sine of x the whole squared plus cos of x the whole squared is always 1. Always. No matter what value x takes. No matter what is the triangle. It's just because of the way the ratios are defined. So this is why we give them names. This is why we create those ratios, because we can study, once we give names to the ratios of triangles, once we are able to deal with them as to this ratio refers to this side over that side and all of that, we are now able to come up with some beautiful results which will hold true for any right angle triangle for any angle. The sine of x the whole squared plus the cos of x the whole squared is 1. So basically, if you pick an angle and you calculate its sine value using a calculator, you can automatically set the cos value. You can just you can square the sine value, and you know that the cos squared should be 1 minus that. So here's a very interesting question. Somebody's asking, is it a sine x the whole squared, or is it sine of x squared? So I'll tell you, this one is not the same as this one. These are two different things, because x is an angle, right? So when you say sine x the whole squared, you are saying opposite by hypotenuse, that whole squared. But if you say sine of x squared, then you're saying the sine of the square of x. So whether it's, so if x is 2, we're saying sine of 4 x squared. They're not the same. But I'll tell you, this is written as this. So it's written like this. These are the same thing. It is not like this, but you can see the difference. It's a sine squared of x. Sine squared x is the same as sine of x the whole squared, because you're doing the sine of x and then you're squaring it. So it's basically like sine times sine of x. It's, when we think of our functions, it's like you're doing sine x and you're doing sine of that. Kind of. You can think of it that way. Sine squared of x is sine x the whole square. So you can either use this notation or this notation. This is different. I'm not saying that's not allowed, it's different. That's not what we were talking about. This is sine x the whole squared plus cos x the whole squared is 1. Okay. Now let us look at one more similar identity. Let's actually verify though whether this formula works. Let's go back to our favorite right angle triangle 3, 4, 5. Let's decide this is our angle x. Sine of x, can you all type in the chat what is sine of x? In this case, what is sine of x? Opposite over hypotenuse is the formula for sine. Good, very good, very good. Oh, somebody says 3 over 4. It's not 3 over 4, it's 3 over 5, because it is opposite over hypotenuse. Opposite over hypotenuse. Okay, good. What is cos? It's 4 over 5. So we have sine squared plus cos squared. So if we do the computations, we get that this is 25 over 25, which is 1. So it works. This will work in any right angle triangle. You can just pick the opposite over hypotenuse and square it and add it to the adjacent over hypotenuse squared. You'll always get 1. That's just the way it is. Okay. So now let us try to get one more formula. Let's go to tan. Do you remember what tan was? Tan is sine over cos. So this is tan. You take sine and you divide it by cos. So that is actually opposite over adjacent. Do you guys remember this? Where sine is opposite over hypotenuse, cos is adjacent over hypotenuse. So tan would be opposite over hypotenuse divided by adjacent over hypotenuse. So the hypotenuse is getting cancelled, it's opposite over adjacent. Okay. Tan is opposite over adjacent, which is sine over cos. Let us see what is in any given triangle, what is 1 plus tan of x the whole square. Let's see what this is. Again, we don't know which triangle it is. We don't know what's the angle. We are trying to use the definition of tan to see what we will get. 1 plus tan squared x. Okay, so let's apply the definition. So we have 1 plus o squared over a squared. Right? Is this okay so far? 1 plus tan squared x is 1 plus o squared over a squared. So let's see how we can add this. Now we have 1 plus o squared over a squared. So the way to add this is we can pick a common denominator. So I can write this as a squared plus o squared over a squared. Do you agree with me? 1 is a squared over a squared. Okay. So going by the same Pythagoras theorem, this is now h squared over a squared, because hypotenuse squared will be the sum of the adjacent squared plus the opposite square, which is what we did in the first theorem. Right? So now I can write this as h by a the whole square. So far so good. I can go very slowly if this is a little confusing. We're just doing algebra here. Right now we're not using any definitions. We're just doing algebra, because once we wrote it as 1 plus o squared over a squared, now we write 1 as a squared over a squared, and then we add them. A squared plus o squared is hypotenuse squared, because adjacent plus opposite is hypotenuse squared, So we have h squared over a squared, and h squared over a squared is the same as h over a the whole square. None of these are 0, so we are allowed to do all of this. Now, what is h over a the whole squared? Like, does this remind you of any ratio? What is h over a? We know what is a over h, right? Can somebody tell me what is a over h? What was adjacent over hypotenuse? What was that ratio? What was adjacent over hypotenuse? Sine is opposite over hypotenuse, right? But what is adjacent over hypotenuse? Cos. Very good, very good. So what is h over a? If a over h is cos, what is h over a? In terms of cos. So if cos is a over h, what is h over a? 1 over cos. Very good. So this is just 1 over cos the whole squared, which is 1 over cos squared. So now we get our second identity. 1 plus tan squared is 1 over cos squared. Let's just pause and let's write the first thing. So the first thing that we got was we got sine squared plus cos squared was 1, and now we got 1 plus tan squared as 1 over cos squared x. Some people are asking me, why are we calling it 1 over cos squared? Don't we have another name? Yes, we do. So remember I told you we have 3 ratios, sine, cos and tan, and then we have 3 other ratios which are the reciprocals of them. It's just that I don't want to use those names now to confuse you. We'll just deal with sine, cos and tan. Only 3 things. And then the other 3 we will come to them some other time. Because it's just names. We can talk about them as 1 over sine, 1 over cos and 1 over tan. But for those of you who are interested, this is called secant squared of x. Because 1 over cos is secant. That's the angle. So there is sine, cos and tan. The reciprocal of sine is called cosec. The reciprocal of cos is called secant, and the reciprocal of tan is called cot. But we will not worry about those 3. We will not worry about cosec, secant and cot. We'll only worry about sine, cos and tan. Opposite over hypotenuse, adjacent over hypotenuse and opposite over adjacent. And just we will see what we can do with this. Okay. So ignore this. Just think that 1 plus tan squared is 1 over cos squared. I hope you understood how I did the derivation. There was not too much of trigonometry, just algebra. We write what is tan, we write what is cos, and we kind of get it. Okay, so let's do the third identity, the last identity. There are only 3 of them. Yes. Okay, so let's look at the third identity. Let's see what we will get if we do 1 plus 1 over tan squared. So we did 1 plus tan squared and we got 1 over cos squared. Let's see what we will get for 1 plus 1 over tan squared. Let's go by the definition. So this is 1 plus, what was tan? Tan was opposite over adjacent. So the 1 over tan will be adjacent over opposite square. Is that okay, guys? Just let me know if this is fine. Tan is opposite over adjacent. So 1 over tan would be adjacent over opposite. All good? If anybody has any question, just raise your hand. Press the raise hand button and I can see. Is this clear so far? Okay, good. So let's see what this is. Let's use the same logic. So we'll have o squared plus a squared over o squared. Just simple algebra. Now instead of writing 1 as a squared over a squared, we write as o squared over o squared. And this gives us again hypotenuse squared over o squared. Do you agree? Because o squared plus a squared is h squared. Opposite plus adjacent squared is hypotenuse. What is this? This is h by o, the whole squared. What is h by o? What is o by h, by the way? So if o by h is something, then h by o becomes 1 over that. Yep. So h by o squared is 1 by sine squared. Because o by h was sine, so h by o becomes 1 by sine, so squared. So the other identity, the last one, is 1 plus 1 over tan squared is 1 over sine squared. So let me write all 3 of them now. Right? These 3 are very important and I hope all of you will remember them. So let us now give names to the other 3 angles. So now that we are comfortable with these 3 and we have come up with a lot of formulae for them, so that we can put those guys here and make this a little simpler, because we have 1 over cos and we have 1 over sine and we have 1 over tan. So for the third theorem, it's very ugly because we have 1 plus 1 over tan square is 1 over sine square, and it's a little irritating to deal with reciprocals all the time. So imagine if we have to do computations with this, everywhere we have to do reciprocal. So let's give the other names. So we had sine, we had cos, and we had tan. So each of them has their reciprocal. We have cosecant, we have secant, and we have cot. I know it can get a little confusing because we have cos, then we have cosec, and then we have sec, and it's kind of, it goes the reverse, because the cosec is the reverse of sine. It would have been a lot simpler if cosec was the inverse of cos and secant was the inverse of sine. We have S and CC, but that's not how it is. Cosec is 1 over sine, sec is 1 over cos, and cot is 1 over tan. So we can write them what they are. So this would be h over o, this would be h over a, and this would be a over o, right? So one is hypotenuse over opposite, then we have hypotenuse over adjacent, and then we have adjacent over opposite. Okay, so this is just a matter of getting used to it, and eventually once you see these guys everywhere, you'll know which is what. But I took quite a while to always remember what is cosec and what is secant. So now let us rewrite our identities for the last time, but using these guys. So the first one remains the same, sine squared x plus cos squared x equals 1. Okay. The second one, now we have 1 plus tan squared. Instead of writing 1 over cosec squared, I'll write it as secant squared x. And the third one, 1 plus 1 over tan squared, which is cot squared, was 1 over sine squared, which is cosec squared. Okay. All good. Okay, we'll do a couple of problems today, and then we will stop. We'll use these theorems, and I hope all of you have written down these theorems, because I won't write them again when I give you the problem, so you can do the problems using these formulae. Although you do realize that any one of these formulae are good enough, because you can then generate everything else. Because just think about it. If you can use the second formula, and let's say we know tan, straight away get secant, from which we can get cos, from which we can then get sine, and then we can get cosec, and then we can get cot. All of those things can be gotten. So we can use any of them, it's left to you. Okay, fine. So let's see. If you know that tan of x is, let's say, 0.7. Okay, if you know that tan of x is 0.7, would you be able to calculate, first question, secant of x, and second question, sine of x? Okay, so let's think about this problem for some time, and let's see if we can get it. So you know that tan of x is 0.7. We don't know what is x. We don't need to know what is x. We just know that the tan value is that 0.7 ratio. Can we use some identities and figure out the other two? Take your time, and once you're done, you could send the answer in the chat. So let's first calculate secant of x. Let's not worry about sine. Let's just worry about the secant. What is the value of the secant? Yep, good. But give me you can use a calculator. You can give me the first 2-3 decimal places if you have a calculator. Otherwise, you can just leave it in square root form. So let's see. I would like if everybody was able to get the value for secant x. Okay, 2 people have gotten it so far. It's correct, whatever you guys have gotten. I'll just wait for others to get it as well. Look at which formula might be the best to use when you know tan, but you don't know anything else, and you want to find out secant. Which would be the best formula to use? Okay, waiting for some more answers. Look at all of them properly, and you can choose which formula you want to use. I've only gotten 2 answers. I'm just waiting for the others. Is anyone finding it hard to calculate for secant? If you had difficulty, let me know. We can do it together. If anyone's not able to understand what we're supposed to do here, how to get secant if we just know tan. Okay. Okay, good. So I'm getting some more answers. Let's see. Just solve for secant, guys. Send me the answer as soon as you get secant. Let's worry about the sine later. Okay, I'll wait for 2 more answers and then I will solve it for all of you. No? Okay. Let's do it together. So what is the identity? We'll use the second identity which says 1 plus tan squared is secant squared. That's the second identity. So we know what is tan. So this is 1 plus 0.7 squared is secant squared. Because we know that tan is 0.7. So 0.7 squared is 0.49. So we know that 1.49 is secant squared. So secant of x is square root of 1.49, which is approximately 1.22. So this is the answer, 1.22. Now let's calculate sine. Now we know secant. So secant was 1 over cos. Right? Secant was 1 over cos. So if secant is 1.22, cos is going to be 1 over 1.22, which is going to be 0.819. Okay, so we got cos. So to get sine, we first get cos of x, which is now 0.819. Now from here, there are 2 different paths that we could take if we want to get sine. So we know cos, we know tan, and we know secant, and we want to find sine. Either we could do sine squared plus cos squared equals 1, or we could do tan equals sine over cos. And personally, I prefer this one because here it's just one simple multiplication. So sine will be tan times cos, right? You take cos to the LHS. We already know what was tan, 0.7. So we multiply 0.7 times the cos value which we just got, which was 0.819, and we get 0.573. So we don't even know what is x. We didn't know what was the triangle, but just by getting sine, we got, sorry, just by getting the value of tan, we got the value for secant and sine. Okay. Thank you so much. So this concludes our intro to trigonometry lecture. We now have 3 identities and we know all the 6 ratios, and we can almost solve problems in trigonometry, and we can just build upon these things. So yeah, thank you so much.